In this lesson, we'll look at the naming of binary acids, as well as learning how to identify oxyacids. We're going to look briefly at hydrates just so you recognize what they are. We're not going to worry about naming those hydrates, but I want you to know these exist. So hydrates have a specific number of water molecules attached to them semi-permanently. If we take cobalt chloride that has been dried, it has the formula CoCl2 or cobalt 2 chloride. If left out in the atmosphere, it actually absorbs water molecules, and every cobalt chloride has 6 water molecules kind of surrounding it. So we have to name it that way as cobalt 2 chloride hexahydrate. Notice there's a dot in the middle with the 6 H2Os. They're attached to the crystalline structure, and we need to include those hydrates in there because if we were weighing this sample, we'd have to include the mass of those 6 water molecules to figure out information about how much that molecule weighs in order to measure out the right amount for an experiment. When we name bases, we name them just like any other ionic compounds. A base is just something that yields hydroxide ions, so OH minus, when dissolved in water. And all we have to do is add hydroxide, sodium hydroxide, lithium hydroxide. Nothing different than what we did for other ionic compounds. We name the metal, and then we name the polyatomic ion OH minus. Other ionic compounds, if we have a transition metal, we have to include a Roman numeral in the name as well. Bases are named just like any other ionic compound. What is the formula for potassium hydroxide? K has a +1 charge. It's in the first column of the periodic table. Hydroxide is a polyatomic ion that has the charge of -1. We crisscross down and get KOH. Therefore, B is the correct answer. Naming acids is a little bit different, and we're specifically talking about binary acids, so acids that contain 2 elements. An acid is a substance that yields H+ ions when dissolved in water, and we'll talk more about acid-base definitions at a later time. When we're naming acids, we add hydro as a prefix and ic as a suffix. For example, HF, we take fluorine and add hydro at the beginning and IC at the ending. So remove the INE and add IC. So we get hydrofluoric acid. For H2S, we get hydrosulfuric acid. This is actually different than sulfuric acid, which you may have heard of, because that's involving a polyatomic ion. Oxyacids are acids which are formed from a polyatomic ion. And we're going to look at these just so you recognize them. You're not going to need to name these anions. We will look at a few that will later have you memorize the name and formula of, but that's a very small group. Notice that we have sulfuric acid, which has sulfate, SO42- in it, and nitric acid, which has NO3- in it. So these are acids which contain an oxyanion, and an oxyanion is just a polyatomic ion that contains oxygens. So these are formed from polyatomic ions. What is the IUPAC name for HI aqueous? And we put the aqueous in there just to indicate that it's dissolved in water, because to name it as an acid, it needs to be dissolved in water. We add the hydro as a prefix, we add ic as a suffix, and then add acid at the end. So C is the correct answer, hydroiodic acid.